Hi everyone, Miss Lorette here. So we're going to be talking about section 2.4 in this lesson. I'm going to show you how to find what's known as the area of basic polygons. You'll want something to write with and something to write on, and probably a calculator at your disposal. Now, if you're in my class or if you have access to the resources I created for my class, I did also create some printable notes for this lesson as well as a formula sheet. So if you have a way to print those at home, it's recommended that you do that to make taking notes a little bit easier. If you don't have a way to print stuff, not a huge deal. It's not a very big lesson. You can just pause the video if you need a little extra time to copy all of the information. So let's just dive right in. Now, in a previous lesson, you guys would have learned how to find what's known as the perimeter of a 2D shape, meaning the length around a shape. So let's take a look at this opening question to start. It says Doug is laying down tiles in his kitchen. Each tile is 1 foot by 1 foot. So here we have these blue tiles. Here's his rectangular kitchen. His kitchen is 9 feet wide and 10 feet long. We want to know how many tiles will Doug need, and also how did you get your answer? So I encourage you to pause the video and think about how you would get an answer and what your answer might be, and then unpause the video and we'll kind of go over it. Okay, so hopefully you've given that some thought. There's a couple different ways that you can get to your answer. As you can see, he started laying down 3 tiles. So what I could do, one strategy I could do here is to count up how many individual tiles will fit inside his kitchen. And I can just count them all up. Another strategy that you could do, some students catch on to this, if I take the width of the kitchen and I multiply it with the length of the kitchen, I end up getting the same answer as if I counted up all the individual tiles. Okay, so regardless if you multiplied like this or if you counted all of them up, you should have found that Doug is going to need 90 tiles total. Okay, so regardless of what method you used here, what you just found is actually the area of his kitchen. Okay, so in a previous lesson, you learned that perimeter is the length around a shape. The area is how much space that shape actually takes up. Okay, so let's go ahead and go to the next slide and define what area is. So take a moment to write this in either your printed notes that you printed or in your notebook. Area. The area of a shape is the size of a two-dimensional surface. Okay, in other words, it's how much space that shape takes up. So AKA how much space that 2D shape takes up. Okay, and something important to keep in mind. Hopefully, when you guys learned perimeter, you learned the importance of always including units in your answer if that shape had units. So if it was, a shape where all the units were feet, you would say that the perimeter was however many feet. When we're finding area, if we're given units, we need to make sure that we square those units. So in other words, for Doug's kitchen, the area would have been 90 feet squared. And it's important to understand that when we square the units, we're squaring the units, not the number. Okay, so maybe let's add that in. Square the units, not the number. It's really important that you understand that this exponent is attached to the feet. It's not attached to the 90, okay? We're not squaring the number 90. We're saying that we're squaring the feet. The reason for this is because if I actually went back to Doug's problem and did 9 times 10 and I included my feet, 9 feet times 10 feet, I'm actually multiplying feet with itself. Well, we've done a little bit of work with exponents at this point, so hopefully at this point you know that when you take something and you multiply it against itself, we can represent that repeated multiplication with an exponent. Since I'm multiplying feet with itself, 2 times, I can represent that with an exponent of 2. Okay, so that's where that exponent comes from. So let's just kind of dive in to all the different shapes that we're going to find the area for. Now, you might be in a class with a teacher who might include some additional shapes, but I'm going to go over some very basic ones in this video and with my class. So if you have the printed notes and the formula sheet, it's a good idea to add the notes that I'm about to include here on both your guided notes as well as that formula sheet. So the first shape that we're going to talk about are squares and rectangles. And the reason I put these two together is because they use the same area formula. So unlike perimeter, every time we calculate an area for a polygon, we use a specific formula for that specific shape. So the first thing that you're going to need to do when you're actually doing problems is ask yourself what type of shape you're working with in order to use the correct formula. A rectangle and a square are going to use the following formula: length times width. Okay, so we usually just use one letter to represent the dimension we're talking about. So L is your length. So this would be my L in this shape, and width would be my W. So all we do is we multiply those two things together. Okay, so again, here for this rectangle, length is my L and width is my W. And as you can see, it doesn't really matter which one I say is the length and the width. When we were looking at that Doug problem, I said the vertical side, the up and down side, that was the width, and then the bottom part was the length. It doesn't really matter because when you multiply, the order of the terms won't matter anyways. Length times width is going to give you the same answer as width times length. Let's do a few examples where we find the area of some squares and rectangles. So I'll guide you through a couple of them, and then I will go to the next slide, pause the video, try them on your own, and then we'll go over the answers. So when I look at number 1, this is a square. It's a square specifically. I know it's a square because the bottom is 3 feet, so the top is also going to be 3 feet. Or excuse me, not feet, meters. That's what the M stands for. And then the right side is 3 meters. So the left side's going to be 3 meters. So it's 3 meters all around. So when a quadrilateral or any 4-sided figure like this is the same all around, and they have right 90-degree angles at the corners, we call it a square. It is still a rectangle, but specifically it's a square. But regardless if it's a square or a rectangle, we use the formula length times width. And notice that when I do this, I'm just multiplying two things here. It's not like perimeter where I'm using all 4 sides. I'm simply using a length and a width, and I'm using each one once. Okay, so I'm going to do 3 times 3 because both my length and width are the same. If I multiply those together, I'm going to get 9. And last but not least, because the shape was given units, I want to put units. And I square my units. I put a little exponent of 2 attached to my meters. The exponent is on the unit, not the number 9. Here's my final answer. I'm going to do the same thing with my rectangle. I have a length of 11.9, or some people might refer to that part as the width, and a width of 4.4. So I'm going to do the same thing. It's a rectangle, so I use my formula length times width, and I'm just going to multiply them together. And to make this a little quick, I'm just going to use my calculator. I encourage you to do the same if you have one. And I'm just going to get a final answer of 52.36. And the last thing I need to do on that answer is include my units. Since this shape had units of meters, I'm going to put meters. And remember, we're squaring those meters, just the units though. Here is my final answer. Okay, so go ahead and pause the video here, give these a try, and then when you unpause, we'll go over the solutions. Okay, hopefully you've given those a go. Hopefully they weren't too hard. Here are the answers that you should have gotten. Number 3 is another square. I know that because the sides are all the same length. So we're going to use the formula length times width, which both of them are the same number. So we're going to do 9 times 9, which will give you 81. And then last but not least, you'll want to include that at the end we have inches squared. We're squaring the inches, not the 81. Number 4 is a rectangle. It's not a square because we have different lengths here. So we're going to use the same formula still, though, length times width. And it doesn't matter the order in which you multiply these two numbers. You could do 4.9 times 9 or 9 times 4.9. It ends up giving you the same answer no matter what, which is 44.1. And just make sure that you include your squared units. So hopefully those weren't too difficult. All right, so the next shape that we're going to talk about are parallelograms, kind of a fancy word, but they're not too difficult. The area of a parallelogram is going to be the following formula, so let's write this down. It's going to be base. I'm actually going to write out the words so you can see it first. Base times height, and oftentimes the way you see that written is just b times h. Okay, so the B stands for base and the H stands for height. Kind of similar to squares and rectangles with one key difference. When you're looking at a parallelogram, which kind of just looks like a slanty rectangle, the base and the height are the two lengths that come together that form this right angle, okay, that form this 90-degree angle. I know they form a 90-degree angle because that little square in the corner tells me they form a 90-degree angle. So you're not using the slanted length, okay? You're using whatever this length would be here because it's what would be forming a 90-degree angle with the base. So the only difference is here, and the reason I showed this is because some of the figures that you might work with might be presented to you like this, where the height, it's actually giving you the height outside of the parallelogram. So these red dotted lines, that's not actually part of my shape. My shape is the shape that's formed by these black solid lines. So this is my parallelogram, the part where my pen is hovering. This part here that's not actually a side of the figure. That's not actually part of our polygon. This part too is not really a side of our figure. It's just showing that if I, took a measuring tape and I measured from this bottom base to the top, that would give me this height, whatever that height is. And then the base is, whatever side forms that 90-degree angle with that height. Here's another way that you might see the parallelogram presented to you, where they give you the height inside of the parallelogram. These are a little bit easier to kind of look at because it's a little more clear what type of shape you're looking at. Over here, this can be a little confusing, but I wanted to show it to you guys because you're probably going to see some shapes where they give you the height outside of the parallelogram like this. So this would be my height. And here, this would be my base. Also notice that if, the parallelogram is kind of on its side, the base might be one of these left or right sides as opposed to the top or the bottom. So they can give it to you right side up with the height inside or outside, or they can give it to you on its side with the height inside the shape or outside the shape. So something to kind of keep in mind. So let's do a few examples, and then I'll give you two to try. So here I'm looking at a parallelogram, and this is kind of similar to the second example I showed you, where it's giving me my base and my height is on the inside. So this parallelogram is kind of sitting on its side because this length right here is my height. It's just kind of sideways. And then this length here is my base. And I know that this shape is a parallelogram because it's like a slanty rectangle. Whenever it looks like a slanted rectangle, it's a parallelogram. Another thing that tells me it's a parallelogram is that if I know that these two lengths are equal, okay, so these two lengths are equal and these two lengths are equal, I can use those little symbols, those congruency symbols, to show that the top and bottom are the same length and the left and the right are the same length. If I know that that's the case, then it's also a parallelogram. That being said, this side of 9.7 might not be what these slanted top and bottom lengths are. Okay, so just something to keep in mind. So I'm going to start with my formula, which is base times height, and I'm going to substitute numbers for those variables. And then I'm going to multiply using my calculator. 9.7 times 5 gives me 48.5. So that's the area that I'm getting. Last but not least, they told us that the lengths of all the sides here are in kilometers. So I need to make sure I add my squared units at the end. Very important to include that exponent of 2. If you don't include the exponent, you're not actually showing that that's the area. So you want to make sure that you're squaring your units. Number 6 looks very similar to the first one that I showed you, where they're actually giving me my height on the outside of the figure, and then my base is right here. So I'm going to use my same formula again, base times height, and now I'm just going to multiply. And it doesn't matter which order I multiply in. I could do 11 times 6 and get 66, or I could do 6 times 11 and still get 66. And the last thing I want to do is I want to include my units. So it's going to be meters squared. So here is my final answer. Okay, so go ahead and pause the video here, give these a try, and then when you unpause, I'll reveal the solutions. Okay, hopefully those weren't too difficult. Here are the solutions that I'm getting for each one. They're both parallelograms. For number 7, we had a height of 3.3 and a base of 8.1. If we multiply those two together, we'll get 26.73 and include your squared units of feet squared. Number 8, we had a base of 11.8 and a height of 7. If I multiply those two together, I get 82.6 meters squared. So let's take a look at another shape, triangle. So the formula for a triangle is going to be the following: 1/2 times base times height. If you're using a calculator, it might be helpful to rewrite that fraction as a decimal. So 1/2 as a decimal is 0.5 times base times height. It's just a little easier to type into a calculator, I think. And kind of similar to parallelograms, there's two different ways that you might see a triangle presented to you. You might see a triangle where one of the corners is a right angle. So we have one of the sides as the height and the other side that it's touching as the base. Or you might see a triangle like this, where it kind of shows a dotted line. This isn't actually a side of the figure, kind of like the parallelogram. This isn't actually part of my shape. We're just using this dotted line to represent the height of the shape. And then the thing that it's touching down here would be the base. Okay, so it's similar to the parallelogram formula, but we have to remember that we're multiplying with 0.5. So we just multiply left to right using those order of operations. So let's take a look at a couple of examples. So in this figure for number 9, we have a height of 6.7 and a base of 8. So I'm going to put it all together in my formula. 1/2 or 0.5 times base, or I should probably start by writing my formula. 0.5 times base times height. And then I'm replacing the base with the 8 and the height with 6.7. And then I'm just going to multiply left to right. 0.5 times 8 will give me 4. 4 times 6.7 will give me a final answer of 26.8, and I'm just going to include my meters squared. I got to include my units. Let's take a look at number 10. So this is one of those examples, kind of like number 9 and kind of like the parallelograms. It's just showing us our height outside of the figure. You can see a triangle like that as well. And then my base is 7 right here. So it's kind of upside down. Again, you could almost say that it's flipped in such a way that this is actually the base and this is the height, because again, if we're multiplying all these numbers together, the order that I do that in is not going to matter. So I'm going to start by writing my formula. 1/2 times base times height. I'm going to replace those variables with numbers. So base is 7, height is 3.1, and I'm going to multiply left to right. 0.5 times 7 is 3.5. I bring down my times 3.1. If you're using a calculator, if you're really careful how you type everything, you can do all 3 numbers at once. But just as a PEMDAS review, I'll do it all in steps. And then the last thing I'm going to get after I write my answer are the units. Kilometers squared is what I want to add at the end. Okay, so here are a couple for you to try. So as usual, we're going to pause the video first, give them a go. Okay, so I did these fairly quickly because I got to get ready for my incoming F channel. So these are the answers that I got, and hopefully we match. Take a moment to kind of review my solutions. Pause the video if need be. And now let's move on to the last figures that we're going to cover today. And this is the hardest, so we kind of saved the hardest for last. These are trapezoids. This has one of the more complicated formulas, so it's very important that when you do this, you're doing order of operations correctly. If you're doing it all in one go in the calculator, again, just be very careful how you type it in. My suggestion is to just follow order of operations and do things in steps. So the trapezoid area formula is going to look like this. We're going to start by doing 1/2 times the height times, and then write it exactly how I'm about to write it. Open parentheses, base 1. So we have two bases. We have a base 1 and a base 2, plus base 2, close parentheses. So what we're going to have to actually do here is we first have to find the sum of the two bases, in other words, add them together, and then multiply with 1/2 times height. And again, it might be a little bit easier to write that 1/2 as a decimal like this. But the key thing here is that when you're doing this, you gotta have these parentheses here. If you don't have the parentheses, you're not gonna find the correct answer. And if you're typing it all in one go in the calculator, if you don't use parentheses, you're not gonna get the right answer. Okay, so trapezoids are kind of like rectangles where the two sides either lean towards each other or one is straight and the other is slanted. So there's a couple different ways that you can see a trapezoid presented to you. Again, you're looking for that height that makes a 90-degree angle with your bases. In this particular example, we have our bases as the two sides, and I know that this bottom part is actually the height because it's making 90-degree angles with the bases. You will never use the slanted sides, so that's kind of key. Don't use the slanted sides. So let's do a few examples, and then we'll wrap up with some that you can try. So here for number 13, I know it's a trapezoid because of the way that it looks. I have a slanted side and a straight side. And I'm going to start by writing my formula. 1/2 times height times the sum of my two bases. I have a height of 7.5. And the two bases are the two sides that the height actually touches, so it kind of connects those two bases in a way. So I'm just going to substitute. I have a height of 7.5, and inside my parentheses, I'm going to add 10 plus 4.2. And again, it doesn't matter if you did 4.2 plus 10. If you're adding these two numbers together first, you're going to get the same answer. So I'm going to follow order of operations, which says I have to do what's in parentheses first. That's going to give me 14.2. And then all of these terms are being multiplied, including the 7.5 and the 14.2. Remember, when you've got a number touching another number that's in parentheses, that's implying multiplication. So I'm just going to multiply left to right. So I'm going to do 1/2 times 7.5 first. That's going to give me 3.75. And the last thing I'm going to do is multiply with the 14.2, and I'm getting 53.25. And I just want to make sure to include my square units at the end. Okay, so that's example number 1. Let's do the next example. Here I know it's a trapezoid again because I've got, two bases connected by a height, and then one of the side links are slanted. So I'm going to do the same thing. I'm going to start by typing or writing my formula. I'm going to have to try and write a little small here because I'm running out of space. And I'm going to substitute. I have a height of 10. My two bases are 5.8 and 12. I'm going to do what's in parentheses first. That's going to give me 5.8 plus 12 is going to give me 17.8. Probably could have done that in my head, but I just wanted to double check. And then I'm going to multiply left to right. I can actually do 0.5 times 10 in my head. That's just taking half of 5, or excuse me, half of 10. I know that half of 10 is just going to give me 5. And then I'm going to multiply 5 with 17.8, and that's giving me a final answer of 89. And I'm going to try and squeeze in my units right here where we can see them. It's going to be meters squared. All right, so go ahead and pause the video and give these two a try, and then I'll review the answers. Okay, I know that these can be a little challenging. Here are the answers that hopefully we match on. So for 15, you should have gotten a final answer of 16.2 miles squared. And for 16, you should have gotten a final answer of 37.8 centimeters squared. Hopefully you found all of these examples helpful. Feel free to rewatch the video if you need to, and be sure to advocate for yourself and ask your teacher questions. And I will end the video here and see you guys next time. Bye, guys.